Okay, so we're going to start with Unit P, Day 6 and 7. They're both small enough we can do them in one day here. But our learning target students will find the absolute value of complex numbers, add, subtract, and multiply complex numbers. So first off, what makes a number complex is that it has a real and an imaginary component. What makes a number imaginary is when it has I in it. And if you remember, I equals the square root of -1. Okay, so if I have the square root of -25, we know that that doesn't exist. There's not an actual number that you can multiply by itself to get a negative. But if I factor that out into a -1 and a 25, so it'd be the square root of -1 times the square root of 25, I've got 5i. And since I'm square rooting, I'm looking for a value here, we would say this is plus minus 5i. Okay, this guy here, can split things up here. I'm going to do a couple. I'll do radical of -1. That makes it 32. And the biggest perfect square that goes into 32 is 16. And that would leave 2. So if I multiply these three together, I get -32. And now I'll do some simplifying. So square root of 16 is 4. Radical 2, nothing to do with that. And then I, we always want I on the end. So since if we're solving, put plus minus. If you're not solving for anything, you don't necessarily need it. But for this one, we'll put plus minus for radical 2i. Now, to find the absolute value, we look at this on a Cartesian plane here. We can make normally you have x-axis, y-axis. Well, now I have the real axis and the imaginary axis. So see how it goes: 2i, 4i. This is 2, 4. So the real numbers going this way, imaginary numbers going this way. So if a point is over here and it's 3 minus 4i, which is what this is right here, we say the absolute value, we're trying to find the distance from the origin. So I'm trying to find the distance from the origin to this point. If you remember, that's a distance formula from P1. Okay, and now the nice thing about this, x1, y1 is 0, 0. So I really don't have to put that. So it'd just be x2 squared plus y2 squared square root. So I'm going to take the square root of the x squared, which is 3 squared plus, and I don't really need to include the negative. It is -4 squared. And we're just doing distance. That's 4 units down. We don't put the I in there because it's just a distance of 4 units down. I don't really need the negative because you're always squaring. So whether it's negative or positive, it doesn't matter. It's going to be positive in the end. So this would be the square root of 9 plus 16. 16 plus 9 is 25. The square root of 25 is 5. So that would be a distance of 5 units from the origin. And this guy here, if you plot it, it'd probably be even easier to see. -5i would be right here. How many units from the origin is that? Well, it's 5 units from the origin. What we could do, what they want us to do, is the x would be 0. So I'm going to 0 squared plus, and then 5 units. Again, you can put a negative or you can skip it. We're squaring, so it doesn't matter in the end. But 0 plus 25, square root that, you get 5. That would have been easier, like we said, just to look at it and see that it's 5. Okay, now below here, we got this table. And the first thing is the additive inverses. We're going to look at how do the real numbers compare with complex numbers. Okay, so additive inverses, it's what you add to a number to get 0. So they must add up to be 0. So what would you add to -6 to equal 0? You would add 6. So the answer is 6. 6 is the additive inverse of -6. What would you add to 10 to equal 0? -10. It's supposed to be a negative, not a plus in there. So -10. So with complex numbers, what would I add to 4i to get 0? So plus what equals 0 would be a -4i. Okay, now this guy, this is a full component. That was just an imaginary number. The real component was 0. Here I've got a real component and an imaginary component. I've got to do both of them. Okay, I've got to cancel out both of them. So plus what will equal 0? Well, what will get rid of that 2? A -2. What will get rid of 5i? A -5i. Okay, so -2 minus 5i would be the additive inverse. Okay, adding like terms. Again, this is just an A. we're just doing real numbers here. This is it's just simply a variable. And we do that because you basically treat I like a variable. Okay, so whenever I'm adding, I'm going to add up like terms. So 6a minus or plus negative 3a is 3a. 1 plus 5 is 6. So 3a plus 6. Over here now, when we write complex numbers, we want to put the real numbers first. Like I have real number and then complex number. So when I'm adding these, I'm going to actually add the real numbers first, just to save some time. So I got 1 plus negative 10, that's negative 9. And then I've got 3i plus negative 5i, so that'd be negative 2i. So we want real first, then imaginary component second. If you're subtracting, this is where students tend to make some mistakes. They're going too fast. When we're subtracting both of these things. Like here, we're subtracting 5x and we're subtracting a negative 3y. So a lot of times, if you struggle with this, I would say add the opposites. So I switch at the plus and I switch the sign, the opposites of these, and now combine like terms. So in this case, since these are just variables, we go alphabetical order, do the x's first, then the y's. So negative 3x plus negative 5x is negative 8x. Y plus 3y would be 4y. Okay. Same thing here when you're subtracting, and this is a complex number here. It has a real and imaginary component. I got to subtract both of those. So I'm going to switch this to add the opposite. So it would be negative 10i minus 1. And now we really should do the real components first. So the only real component I see here is negative 1. So negative 1. And then the imaginary components, I got 4i and negative 10i. I'm adding together, so minus 6i. Okay, now multiplying, you're taking, when it says 3a, you're actually taking 3 times a times 4 times a. And with multiplication, you have the commutative property. You can switch the order anytime you want. So I could actually do 3 times 4, which is 12, times a, which is a squared. Same thing over here. 4i is really 4 times I times 5 times 5i. So 4 times 5 is 20. And then I times I is I squared. We mentioned above that I is the square root of negative 1. I equals the square root of negative 1. So that means I squared would be square root of negative 1 squared, or just negative 1. So anytime you see an I squared like this, you can cross it out and multiply by a negative. So it's actually negative 20. Okay, so there's, and that's really, that is why we have imaginary numbers, because you can still do operations with them. You can multiply and get a real number. Even though neither one of these numbers exists, when I multiply, I do get a real number. So that's why why are we even doing this? Well, that's why. It's because you can do operations with them. And now FOIL, same thing. I'm going to speed things up here. So I did first, outer, inner, last, and then combine like terms. So I've got negative 10x plus 3x is minus 7x minus 5. So same idea over here. I'm going to do first, outer, inner, last. And then I'm going to combine like terms. Now, before I combine though, I should look right here. I've got another one of those I squared. So anytime you have I squared is the same thing as negative 1. So that'd be a positive 8. So 3 plus 8 is 11. And then it'd be plus 2i. So I'll flip the paper over. And we're going to do some dividing. So if you remember, when you divide, you're really not dividing. You're just simplifying and getting the radical out of the bottom. So both of these, I don't want a radical on the bottom. I represents a radical, square root of negative 1, so I just want to get them out of the bottom, really. So you do that by rationalizing. If it's a single radical like this, just multiply it by itself. Because radical 3 times radical 3 is 3, and then on top I got a radical 3. So if you type this in the calculator and type that in the calculator, exact same decimal. Okay. Now this guy, when you got a binomial like this, the only way to do it is by multiplying by the conjugate. The conjugate is going to be the same numbers, but a different sign between them. So the sign between them gets switched. Okay. I'm going to do some multiplying. And the cool thing about the bottom here, when I do the first, outer, inner, last, because I picked the conjugate, the outer and the inner cancel out. So I really just need to do the first and the last. So radical 3 times radical 3 is 3. And that'd be negative 4, so that's a negative 1. Anytime you're dividing by -1, you really just switch the signs up above. So this would be, my final answer would be 2 minus radical 3. Now on this side, if I have an I by itself, I can just multiply by that. The 2 is not the problem. Now you could multiply by 2i, but I'm just going to do I over I. And this will give me an I over 2i squared, which is actually a -2 on bottom, so a negative I divided by 2. Same thing as before, if it's a binomial, got to do the conjugate, which just means switch the middle sign and then multiply. Same idea as over here. Because our conjugates, the outer and the inner products cancel each other out. So I could just do the first and the last. So we have 4i squared minus 1. Again, I squared makes that negative, so this is a -5 on bottom. Because the bottom's negative, I need to move that to the top, so it would be a -2i plus 1 over 5 would be my final answer. And this right here, I already did that. I took care of that. The I squared actually equals -1 part. Okay. Now, below here, the big idea is there's two main ways to do graphically. Okay, so algebraically, we would want to get this 0 by itself on the other side, factor, and see what we got. Okay, so I've got 0 by itself. Now I'm going to factor, and I get 2x plus 3 and x minus 5. And that means that we got two numbers here to look at. There's critical points here, so that would be -3/2 and 5. And you'd say, well, is it less than, greater than? Well, how do I write my answer? That's where graphically comes in. So think this is a parabola. It's open up. We want to know what x values would the parabola be below 0. So let's say this was 0 or the x-axis. So that means all of these y values are less than 0, so it's all of these x's that we want, which happens to be from -3/2 to 5. Those are the breaking points. Okay, so when we get these answers, my final answer is saying what x values would give you a value less than 15 or 0 here, so we put it under the x axis. That means any x between 3/2 and 5, with 3/2 and 5 being included, would work. Okay, so this part of the u satisfy being less than 0. If you want to do it graphically, you would just type this into the y equals. So I typed it in, I hit graph, and I got this shape. And since it says less than 0, I want to know when is it below the graph. It'd be from this x value to that x value, and that's where you could go second calc and check your zeros. Okay, I believe we did that earlier. Okay, now on this guy, again, graphically, you can put in the calculator. It is a U shape, and it wants to know when it's greater than 0. So I'm going to have this U shape. I want to know when's it greater than 0. There's going to be two intervals where it's greater than 0. So I went from this x value going that way and this x value going that way. I could graph it, look for zeros, or algebraically I could find those zeros also. So I'm going to factor that, and I get that x, when x is 2 and x is 3, something's happening. Well, here's the 2, here's the 3. So my intervals would be from -infinity up to 2, including 2, in union with, and then it'd be from 3 on to infinity. If you remember that u just means or, so it could be this or that, any of the x values in either one of those. Okay, so I'm closing in on 1 minute left because I'm only allowed to do 15-minute videos, so I'm going to go fast here. So these are both absolute values, which means when I graph them, I'll have V shapes. Okay, so my option, I had two options. I could get it 0 on a side by itself. So on the left, I could graph this, where I brought the 17 to the left side, and I just type this in y equals, and I'm looking for when it equals 0, so I check those zeros. Or you could type in two separate equations, and you could graph both of those, and you look at where they intersect each other. It's the same answer either way. So do this one with zeros, or this one with intersect, option under calc. For this one, it's when it's less than, so when is a red below x, it'd be this interval from here to here. If it's outside, greater than, it'd be on like that on the outside. Remember, you set these equations up with absolute value, and then solve to get these two answers.